So I'm Brandon Clark. I've been working on the Dr. Memory project. So a little bit of background. Over the summer, I did Google Summer of Code and I started on this kind of piece. And what I did over the summer is I made a Dr. GUI, which is a graphic application framework for DynamoDB. So people can make plugins with Qt5 and then link it into this framework. And it'll present it forward and they can use it. And it'll give like a front end to whatever tool they want to make on top of DynamoDB. And also I use that framework to make a plugin for Dr. Heapstat. So a little bit of background about Dr. Heapstat. It's basically a heap profiler. It sits on top of DynamoDB and analyzes all the heap usage of your application. And it outputs like a couple different statistics and different log files. So every once in a while, given a specified time interval, it'll take a snapshot of your application. And it'll take the call stacks and how much memory you're using. And it'll record all the frames for like call stacks as it goes. And at the end, if you have a large application, you'll end up with several gigabyte file for like snapshots and for call stacks. Staleness too. So what staleness is, it is basically a form of a memory leak, but instead of an actual memory leak, you could have deleted this so many seconds ago and you didn't. You're wasting space. So it lets you see that too. So you end up with a couple of gigabytes of files that each are can be up to a million lines long. So it's not the best way to go through the data from the application. You're not going to get any use out of that. So I used to have a visualizer. Yeah, this is the old one. I don't know why most means not working. It's probably because it's IE. But so this is the old one they used to have. It was written years ago, and they stopped using it because it didn't really work all that great. It used Flash for the front end, and then it had a Perl server on the background because Flash has some bottlenecks with how much memory it can handle, all at once. So they're using a Perl server to serve up data to it, and it was really, really slow. And I'll talk about a couple of what each of these frames are when I go through mine. So I had a demo, but at 3:40 I realized that my laptop doesn't have a VGA port. So I can't do that, so I had to grab some screenshots. So yeah, no demo. So it's unfortunately really small. I'm making it bigger.
Yeah, 11 now.
Huh?
I'm trying to zoom.
It'd be nice if their full screen button worked. So this is a screenshot from my desktop. So in this top area over here, this is a graph of the snapshots over time. And you can see up here the different bytes and how many bytes are being used. So in this specific application, it's going up over time and just kind of all ends. It's I forget what application this is. And then on the right-hand side here is basically a table of all call stacks and a specific snapshot. So this giant vertical bar over here displays which snapshot you're currently selecting from the graph, and then it changes a bunch of the controls over here and updates it with info from that specific snapshot. So you can see the call stack number. You can see the first couple frames. So if you're quickly scrolling through this call stack, a table trying to find something specific, you can see the first couple frames. You can get some data out of that. And you can also see the total memory usage for the snapshot. There it's like 153 kilobytes. And then you have a bunch of them. And there's I have a preferences section that I can get a snapshot of. This view down the bottom is the frames of a specific call stack you can choose from the table up top. The graph has zooming, so if you right click and you drag, you can't fix it. And it zooms on a specific section, so there's this level of detail that you can't see because you have too many snapshots, then you can zoom in on that. These different lines correspond to different memory usage. So the orange line down the bottom there is like the memory that was actually requested by the process. The green line is that plus any padding that was given to you by the operating system. And there's also the blue for the heap headers. You can see all of those. The bottom left control is you can run Dr. Heapstat from there. You can grab you give it the Dr. Heapstat location of the target, and any options of both, and you run it. It'll come up with a window asking if you want to load the data set right now or just ignore it. Let's see what else I have. So this is another view for snapshot. On the bottom right, it's a tree structure, and it breaks all of the frames down into usable sections. So the top level of the tree is executable files. So you can see the Dr. Keepstat library is at the top, it's we have it selected, and then right below it is libc, and then below that is the actual CFRAC executable. And underneath those are source files, if debugging symbols are loaded. If it doesn't have those, it just puts a question mark because there's no way it came from. And then organize and keep source file are the actual frames, and you can click on a line number or double click on it and open it up in a window that you can either configure to use our default code editor, or you can configure it to use yours. So you can see, oh, what was actually on this line, and you can double click it and see, oh, okay, it's there, and close it. It counts the number of occurrences in the snapshot of each frame, and also totals it for the source file, so you can see how much memory you're using for a given frame or a given source file. Also here is on the giant red thing is a graph of stamless. So stamless is what I described earlier, and you can also zoom on this one to use the same parent class as the top-up graph. And each of the bars represents a call stack, and then it shows how much, like how many bytes are stale for a given point in time in that snapshot. So the bottom controls here in each graph, you can search through this, like the process lifetime for the staleness. So that you can see, hey, I want to see it's everything that's been stale for 15 snapshots or for like the entire process lifetime. Here is things that have been stale for at least 0 snapshots. So it's going to display all the staleness from a given snapshot up until that point. Then in this graph up here, the purple line that's sort of hidden by the orange one, it was originally hidden, but I offset it a little bit so that you can see it. Nice. That'll actually adjust as you go. So you can see that this graph had this purple line here represents like at each snapshot, it's the total amount of memory that's being used for I think at least 50 snapshots. Alright, so what I have left to do for it is Dr. Keepstat perfectly outputs a text file, which as I said before is really, really big. So it's not like good for human consumption. And I want to switch that from text to like a binary format so that it's way easier to read in the files to be analyzed by my viewer. Because with the really, really big files, it take like up to a minute to read like all the data in. I also want to improve the current queue caching system. So over here, when you select a snapshot, it has to load a bunch of the data, and it's basically holding a lot of stuff in memory. So when you have to select a view, it can take like a little bit of like processing to actually load the view. So I keep those in memory, and it doesn't take up too much memory. So it saves a lot of processing, so there's no lag when sliding between snapshots. But up to a certain point, it gets to be too much, and actually there's a lag anyways. So I have to put a cutoff there. I also want to remove unnecessary views, like view refresh / redraws. So I noticed that in my debug output, it's going through functions like twice. It doesn't really need to. So I need to go through that and kind of redraw or re-evaluate what the order is for doing different functions and make sure that things aren't being done twice unnecessarily. Also, this is all on the documentary repositories. If you guys want to run it on your app, you can play with it and see if there's anything wrong immediately, then break it or whatever. For the rest of the semester, the Mario tools, currently the front ends are Perl, and that's a really big pain. Derek, the primary author, wants to change that because we're using Perl. So we're going to switch it to C, and the main problem, like we're doing that like mainly for like cross-platform, is character encodings. So Mario has to be able to accept like, all character encodings for input, but Windows, like a while ago, was like, oh, let's be ahead of the game and accept international characters. So they went with UTF-16. That was before anybody else had really implemented that. And then everybody else said, oh, let's go UTF-8. So Windows is the only people using UTF-16 for like a lot of their syscalls. So the tools like Dr. Keepstat, Dr. Memory, I think of the other ones right now. They all pretty much have their own code to handle the input. It's all separate. And it's all like a little different. We do thing that can be specific for one or the other, and it's duplicate code. So it's kind of silly for that. So we're gonna, while I'm switching it all over to C code, so that it's like cross-platform, I'm going to set it up so that there's going to be a library that the tools can just grab from Maria and have it all be singular and straight out. Does anybody have any questions about that? Oh, also, I'm using Qt5 for the visualizer. Qt works with Python and C++, and I recommend it if anybody wants like a client-side graphic application. Because they can do a lot of cute things. They also have cool things. They also do like QML and stuff that other graphic things. Yeah.
Yes. Is Heap in the sense of dynamic memory, is it the same term as, or derived from the same thing as that Heap is in the data structure, the tree with each node being either greater than or less than each of its child nodes?
You would be surprised if that was true. As far as, it's just the second, it's 2 pieces of memory. You get your application as a stack, they use that, and then you can allocate dynamic memory. And you can
Okay.
I don't think they store it as I don't think they store the heap as a heap.
So, I'm saying, like, if the names are related,
Google it. The primary authors of Dr. Maria, Dr. Mary, etc. And also thank you, Professor Morgan Goldschmidt, and you guys.